Scientists have successfully identified two of the earliest building blocks of the Milky Way galaxy. Greetings everyone. Today's video will focus on the remarkable findings of astronomers from the Max Planck Institute for Astronomy. They have successfully pinpointed two ancient fragments of proto-galaxies which merged with an early version of our very own Milky Way approximately 12 to 13 billion years ago, during the nascent stages of galaxy formation in the vast expanse of the universe. These fragments, aptly named Shakti and Shiva, were identified through the meticulous combination of data obtained from ESA's astrometry satellite Gaia and the SDSS survey. This groundbreaking discovery has the potential to shed light on the early origins and growth of our beloved Milky Way, ultimately helping us unravel the mysteries of its transformation into the magnificent galaxy we know today. Without any further delay, let us dive into our captivating discussion. During the early stages of the Milky Way, smaller galaxies joined together to create larger structures. Recently, Kayati Malhan and Hans-Walter Rix from the Max Planck Institute for Astronomy have successfully identified two potential building blocks that have remained recognizable to this day. These proto-galactic fragments, known as Shakti and Shiva, merged with an early version of our Milky Way approximately 12 to 13 billion years ago, marking the beginning of galaxy formation in the universe. By combining data from ESA's Gaia satellite and the SDSS survey, astronomers were able to pinpoint these components. This discovery is comparable to finding remnants of an initial settlement that eventually grew into a thriving modern city. When galaxies collide and merge, various processes occur simultaneously. Each galaxy carries its own reserve of hydrogen gas, which becomes destabilized upon collision, leading to the formation of numerous new stars. Naturally, the galaxies that are merging bring along their own pre-existing stars, resulting in a mingling of stars during the process. Over time, these accreted stars will contribute to the overall stellar population of the newly formed merged galaxy. While it may appear challenging to determine the origin of individual stars once the merger is finalized, there are indeed methods available to trace back their ancestral lineage. The assistance we seek can be found in the fundamental principles of physics. When galaxies collide and their collections of stars intermingle, the majority of these stars retain their basic characteristics, which are directly tied to the velocity and trajectory of their original galaxies. Stars that originated from the same galaxy before the merger exhibit comparable values for both their energy and what physicists refer to as angular momentum, the momentum associated with their orbital or rotational motion. In the gravitational field of a galaxy, the energy and angular momentum of stars remain constant and unchanging over time. By identifying clusters of stars that possess distinctive and similar values for energy and angular momentum, there is a high likelihood of discovering a remnant resulting from a galactic merger. Identification can be facilitated by considering additional factors. Stars that have formed more recently are characterized by a higher concentration of heavier elements known as metals compared to stars that formed in earlier times. The metallicity of a star, or its metal content, can serve as an indication of when the star likely originated. When searching for stars that existed 13 billion years ago, it is important to focus on stars with extremely low metal content, referred to as metal-poor stars. The ability to identify stars that originated from other galaxies and joined our Milky Way has only recently become achievable. This task requires extensive and high-quality data sets, and the analysis involves employing clever techniques to identify the specific class of objects being sought. These types of data sets have only been accessible for a limited number of years. The astrometry satellite Gaia, launched by the European Space Agency, ESA, in 2013, provides an ideal data set for conducting this type of large-scale galactic archaeology. Over the past decade, Gaia has generated an increasingly precise data set that includes the positions, positional changes, and distances of nearly 1.5 billion stars within our galaxy. The study of stellar dynamics within our galaxy has been completely transformed by the groundbreaking Gaia data, which has already uncovered previously unknown structures. One significant discovery is the Gaia Enceladus sausage stream, a remnant of a major galactic merger that occurred between 8 and 11 billion years ago. Additionally, two structures have been identified more recently in 2022. The Pontus Stream, as identified by Malhan and colleagues, and the Poor Old Heart of the Milky Way, as identified by Rix and colleagues. The latter is a group of stars that originated during the initial mergers that formed the Proto-Milky Way and have since remained in the central region of our galaxy. To conduct their search, Malhan and Rix utilized Gaia data in conjunction with detailed stellar spectra from the Sloan Digital Sky Survey, DR-17, which provided valuable information regarding the chemical composition of the stars. Malhan explains, "We observed that, within a specific range of metal-poor stars, there was a noticeable concentration of stars around two distinct combinations of energy and angular momentum. Unlike the Poor Old Heart that was present in those plots, the two clusters of stars with similar characteristics exhibited significantly greater angular momentum. This aligns with the behavior of star groups that originated from separate galaxies that later merged with the Milky Way. These two formations have been given the names Shakti and Shiva, with the latter being a prominent deity in Hinduism and the former representing a female cosmic energy often depicted as Shiva's companion. With their comparable low metallicity and energy and angular momentum values, Shakti and Shiva possess the potential to be among the earliest precursors of our Milky Way. According to Rix, these two celestial bodies could be the initial building blocks of the Poor Old Heart of our galaxy, kick-starting its evolution into a grand-scale galactic entity. Over the next few years, numerous surveys, some of which are already underway while others are yet to commence, are expected to provide significant additional data. These surveys, such as SDSSV, 4 MOST, LSST Rubin Observatory, will offer valuable insights into both spectra and precise distances. With this wealth of information, astronomers will be better equipped to determine whether Shakti and Shiva truly offer a glimpse into the earliest prehistory of our home galaxy. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.